In this video, we're going to go over how to compute 2x2 and 3x3 determinants. So for this question, I want you to pause and try to do it yourself first. So first, we focus on this diagonal and do 1 times 7 minus 3 times 1. 7 minus 3 equals 4. So the determinant of this matrix, which we'll name A, is equal to 4. The next matrix I'd like you to compute is this one. All right, so first, this diagonal, 80 minus 21. 80 minus 21 is equal to 59. So the determinant of this matrix equals 59. For the next matrix, I want you to try to do this one on your own. All right, so the first thing you want to do is notice for each row, they're the exact same for the columns. All 1s, all 3s, all 5s. The first thing I want you to do is choose any row. Now take this row and subtract it by the other rows. So 1 minus 1 is 0, 3 minus 3 is 0, and 5 minus 5 is 0. All right, now remove the very first row or the very first column and the row that you chose. And now what you're left with is a matrix consisting of all zeros. 0 times 0 equals 0, minus 0 times 0, which equals 0. So what you want to do is take A times D minus B times C, and that will be the determinant of the matrix. All right, for 3x3 matrices, you have A, B, C, D, E, F, G, H, I. So the first thing that you want to do is take A, and then you're going to have a matrix with E, F, H, I, minus B, D, G, F, I, and then plus C, D, E, G, H. All right, so here is both of the main formulas. The next matrix we'll look at is this one. So first, take 1 and 0, 0, 1, 2, minus 3, 7, 2, 0, 2, plus 5, 7, 0, 2, 1. All right, so now we can compute these three matrices. So 0 minus 0 equals 0 times 1 equals 0. 7 times 2 is 14 minus 0. So 14 times 3 will be 42. 42 minus 0 equals negative 42. Over here we have 7 minus 0 equals 7. 7 times 5 is 35. 42 plus 35 equals negative 7. So the determinant of this matrix will be negative 7. All right, for our final question, we have, given the matrix A, assume that the determinant of A equals 10. A is a matrix 2 times 2, so it's a 2 times 2 matrix. What is 2A? So the formula for this can be written as determinant of the determinant of CA equals C to the power of n times determinant A. If you recall, determinant A is 10. And the matrix A was a 2 by 2 matrix. C is 2. So 2 to the power of 2 times 10. This n represents the dimensions of our matrix, which in this case is 2. So 2 times 2 equals 4, times 10 equals 40. So the answer to our original question is 40.